Here we have classic LeetCode problem number 704, binary search. Now, binary search is an extremely important search algorithm for any computer science student or professional to have an understanding of and know how to implement. So, before we get started in the description of the question itself, the first thing you need to remember is binary search is always O of log n. And you can remember that because in binary search, you're always cutting the array in half and then checking that half, cutting the array in half, checking half. So it's cut in half. So n is the number of elements in the array, but it's log n because you keep cutting in half using the binary search algorithm. So in the problem statement, it says, given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search for the target in nums. If the target exists, return the index of the target. Otherwise, just return -1 if it doesn't exist. And it's important to remember it has to be sorted in ascending order, otherwise this whole binary search algorithm wouldn't work. So luckily this is an easy LeetCode problem, so it's already given to us in a sorted ascending order, right? And binary search, once you understand the basic fundamentals of it, it shouldn't be too hard to implement. But we can look at this test case here, where the target is 9 and this is the array, and the output should be 4, right? So I just wrote it out here to make it more clear. Here's the array, and I just wrote the index of each element under each element just for clarity, so it's 0 to 5. And when you do binary search, you wanna cut the array in half based on where the element is, right? So the first thing you need to do is you need to find the beginning of the array, and we call that low. So of course the beginning of the array is always 0 because 0 is the first element of any array. Now, we also want to find the end of the array. We call that high. So what is the end of the array? It's the length of the array minus 1. So in this case, the length of the array would be 6 because there's 6 elements, and -1 would be 5. So that's the index of the end of the array. We can call that high. And now we want to, in binary search, we want to loop. After we get these initial variables initialized, we want to loop, and we want to, the very first thing we want to do in the loop is basically update the mid. And by the way, it'll be a while loop while low is less than high. If these ever cross over, become equal, or is low is equal or greater than high, that means it's checked every possible element, and it's for sure not in nums. So if the while loop breaks, we can return -1. But in this case, the target is 9. I'll write that right here, just so it's a little bit bigger. The target is 9, right? So that is in the array, so we don't have to worry about the while loop breaking, right? Now, let me explain basically the most important part. It's finding the middle of the array. So the middle of the array, you could say, okay, in this case, since there's an even number of elements, you're not going to get exactly the middle, but let's say you just want to choose the one that's off center to the left, and that's your middle, right? So it would be index 2. What could you do? You could do high divided by 2, right? 5, which is high, divided by 2, which is just cutting it in half, is equal to 2.5. But remember, in Java, when you're dividing integers, it just chops off the decimal, so you just have 2, right? So that would actually give you the correct index that we're looking for. We want to find the general middle point of the array, which could be 3, right? The element 3. But that would only work in this when it's initially when these values are initialized as the start and the end of the array. We always want to find the correct middle based on the current low and high. And the low and high will be updated depending on where the target is. So let's say we're here. We say, okay, we found the middle. Is this middle equal to the target? It's not, so we can't return this index, right? And we know the target is 9, so 9 is greater than 3. So we want to check this way. We want to check the right half of the array. So what would we do? We would update low to equal index 3, right? So in that case, if low is equal to index 3, and high stays index 5, because we're checking the right half, we can't just do 5 divided by 2 and get 2 as the middle, we want to update the correct middle. So how would we do that with the middle of index 3 and index 5? Basically using this formula here, relatively simple, but if you haven't seen it before, it may be hard to come up with, but basically it's low, which is in this case is now 3, plus high, which is 5 still, we didn't update that, minus low, which is 3, divide by 2. So that would be 3 plus 2 divided by 2, which is essentially just equal to 3 plus 1. So we know it's 4. So this gives us the new middle, which is exactly correct, right? And then once we update the new middle at the very beginning of the while loop, we always want to hit this check again. We want to say, is the middle, actually it would be nums at mid, because we want to see if the element itself is equal to the target element. In this case, nums at 4, which is the new middle, is equal to the target. So all we do is we would return mid, which is the index of the target. So that would be a correct return value. And then as you can see, we update when it was greater, essentially it was this way in the array to the right, we would update the low to be 1 plus the mid, the previous mid, which was 2. So we'd update the low to be 3, right? But let's just say, for example's sake, the target is like 0, right? What would we have to do in that case? Let me just erase this circle to make it clear. In that case, we wouldn't update the low, we would keep it the same, and we want to cut the array in half based on checking left. So we would update the high to be the middle value, which if you remember, the previous middle value was 3. It was 3, which is index 2. Middle value minus 1, right? So the middle value minus 1 would be 1. So we would check these two values in the while loop, and we'd continue until we return the target, which would be the middle. So yeah, that's pretty much it for both cases, whether we want to cut it in half based on checking the upper half of the array, or cut it in half based on checking the lower half of the array, and that would just repeat over and over again in a while loop. And I'll show you exactly how to do it in Java code. And again, this solution is O of log n. Alright, so here we are in the Java code on LeetCode, obviously, and I'm going to be coding out the solution that I just previously explained, and hopefully this code makes a little bit more sense based on the explanation that I gave. So as I said earlier, the first thing you want to do is you want to get integer to represent the start index of the array, and an integer to represent the end index of the array. So you can call it start end, you can call it low high. That's what I'm going to use. It doesn't really matter the names itself, but so int low is always equal to 0, because 0 is always equal to the start of an array in any case. Then int high is equal to nums.length minus 1. The length minus 1 is always equal to the last element of the array, right? Then we want to loop while low is less than or equal to high. And basically we want to loop while this is true, because if this ever becomes a case where low is greater than high, that means we've already checked everything possible in the array and we didn't find what we're looking for. We didn't return it. We didn't return what we're looking for. So if this loop ever breaks, that means we've checked everything and we couldn't find it, so we could just return -1 as it specifies in the problem statement. But obviously we have to carry out the binary search before we can conclude that. So in order to carry out the binary search, as I said earlier, we need the middle value. So int mid is equal to low plus high minus low. Well, let's type lol divided by 2. So this will always give you the correct and most updated mid value the start of every iteration of this while loop, right? If, like, you could say, okay, the middle value at this very start is just high divided by 2. So why can't we do mid equals high divided by 2? That'll only work for the first iteration, but once we update the low and high values, we need to calculate the new and correct middle value. So this little calculation here will do that for you. It's good to remember this, so because it's always used to find the middle of an array in binary search, right? So now we want to check if nums at mid. So if the middle element is actually equal to the target, then we're good. We already know what to return. We just return the index, the middle index, which is mid, right? If that's not the case, so if target is greater than the middle element, since the nums array is sorted in ascending order, we know we can just throw out the whole bottom half of the array and only check the upper half with the greater values. So in this case, we would just update the low to make it equal to mid plus 1. And what this would do is the new start, quote unquote, start of the array will be starting at mid plus 1, which is 1 past the middle value. And the reason for that is we already checked the middle value in this if statement here, and we know it isn't that value itself, so we would do 1 past it, and we would throw out the middle value and all the lower values in this case, right? But there is a case where if target is less than nums at mid, we would have to keep the low value the same, and we'd have to throw out the upper half. So we would do high is equal to mid minus 1 this time. It's minus 1 this time because we're checking lower, and lower would be to the left. So high is equal to mid minus 1. We already checked mid, and we want to go left of mid, right? So this would just throw out the upper half. And yeah, it's as simple as that. And this would just keep looping, doing binary search until either it finds a value and it returns that index, which would be the mid, or it returns -1 because it couldn't find it and this loop breaks. So let's see if this runs properly. Alright, looks like it's accepted. Let's see if it passes every test case that LeetCode throws at it. And yeah, it looks like we're good. Yeah, this solution is O of log n. And if you want to stay up to date with the best coding knowledge, and you want to work on improving yourself and improving your coding skills, please go ahead and subscribe right now, and I'll see you in the next video.